According to the National Electrical Code, an overcurrent protection device, or OCPD, is required for surge arrestors installed on the line side of a service panel. The OCPD must be sized appropriately to protect the surge arrestor from being damaged by overcurrent conditions. The National Electrical Code does not specify a specific size for the OCPD, but it recommends that the OCPD be sized according to the manufacturer's instructions. Power companies often install surge arrestors directly to the meter lugs without an OCPD. This is because the power company's distribution system already has OCPDs installed, so an additional OCPD is not necessary. Hooking up a surge arrestor to a larger breaker does not provide any additional surge protection. The size of the OCPD is determined by the maximum current that the surge arrestor can handle, not by the amount of surge protection it provides. The size of the OCPD for a surge arrestor should be selected according to the manufacturer's instructions. There is no advantage to hooking up a surge arrestor to a larger breaker. Square D surge arrestors come with their own internal overcurrent protection, so an additional OCPD is not required. However, it is recommended to install a disconnect switch or circuit breaker on the load side of the surge arrestor for maintenance and safety purposes. Let's delve deeper into the specifics. Firstly, it's essential to understand the function of a surge arrestor. A surge arrestor, also known as a surge protective device or SPD, is designed to protect electrical equipment from voltage spikes or surges. These surges can be caused by lightning strikes, utility switching, or even the operation of heavy electrical equipment within a building. When a surge occurs, the surge arrestor diverts the excess voltage to ground, preventing it from damaging sensitive electronic components. The overcurrent protection device, or OCPD, plays a crucial role in protecting the surge arrestor itself. If a surge arrestor is subjected to an overcurrent condition, such as a short circuit, it can be damaged or even fail catastrophically. The OCPD, typically a circuit breaker or fuse, is designed to interrupt the flow of current in the event of an overcurrent, protecting the surge arrestor from damage. The National Electrical Code provides guidelines for the installation and protection of surge arrestors. While the NEC doesn't specify a specific size for the OCPD, it emphasizes the importance of following the manufacturer's instructions. This is because surge arrestors from different manufacturers may have different current handling capabilities. The manufacturer's instructions will typically provide a recommended range of OCPD sizes to ensure adequate protection. It's important to note that the OCPD should be sized to protect the surge arrestor, not the load that the surge arrestor is protecting. The load is protected by its own dedicated OCPD. The OCPD for the surge arrestor is solely for the purpose of preventing damage to the surge arrestor itself. Now let's consider the practice of power companies installing surge arrestors directly to the meter lugs without an OCPD. This is a common practice, and it's generally acceptable because the power company's distribution system already has OCPDs in place. These OCPDs are designed to protect the entire distribution system, including the surge arrestors installed at the meter. In this scenario, the surge arrestor is effectively protected by the upstream OCPDs in the power company's system. However, in a residential or commercial setting, where the surge arrestor is being installed on the load side of the service disconnect, an OCPD is typically required. This is because the surge arrestor is not protected by any upstream OCPDs, and it needs its own dedicated protection. The question arises whether using a larger breaker provides better surge protection. The answer is no. The size of the OCPD is determined by the maximum current that the surge arrestor can handle, not by the amount of surge protection it provides. A larger breaker will not improve the surge protection capabilities of the surge arrestor. In fact, using a breaker that is too large can be detrimental. If the breaker is too large, it may not trip quickly enough in the event of an overcurrent, allowing the surge arrestor to be damaged before the breaker interrupts the flow of current. Therefore, it's crucial to select an OCPD that is sized appropriately for the surge arrestor, following the manufacturer's instructions. To reiterate, selecting the right OCPD involves determining the maximum current the surge arrestor can safely handle. This information is typically found in the manufacturer's specifications. The OCPD should be sized to trip before this current is exceeded, thus protecting the surge arrestor from damage. Using an OCPD that is too small can also be problematic. If the OCPD is too small, It may trip unnecessarily during normal operation, interrupting power to the surge arrestor. This can be inconvenient and may also reduce the lifespan of the OCPD. Therefore, it's important to select an OCPD that is large enough to handle the normal operating current of the surge arrestor, but small enough to provide adequate overcurrent protection. In the case of square D surge arrestors, many models come with their own internal overcurrent protection. This means that an additional OCPD is not required, as the surge arrestor is already protected from overcurrent conditions. However, even with internal overcurrent protection, it's still recommended to install a disconnect switch or circuit breaker on the load side of the surge arrestor for maintenance and safety purposes. This disconnect switch or circuit breaker can be used to de-energize the surge arrestor for maintenance or replacement, without having to shut down the entire electrical system. This provides a convenient and safe way to work on the surge arrestor. The disconnect switch or circuit breaker should be sized appropriately for the surge arrestor, following the manufacturer's instructions. It's important to note that the disconnect switch or circuit breaker is not intended to provide overcurrent protection. Its sole purpose is to provide a means of disconnecting the surge arrestor from the electrical system. In summary, when installing a surge arrestor, it's crucial to follow the manufacturer's instructions regarding OCPD sizing. If the manufacturer recommends an OCPD, it should be sized appropriately to protect the surge arrestor from overcurrent conditions. Using a larger breaker will not improve surge protection, and may even be detrimental. In the case of square D surge arrestors with internal overcurrent protection, an additional OCPD is not required, but a disconnect switch or circuit breaker is recommended for maintenance and safety purposes. Always consult the National Electrical Code and local electrical codes for specific requirements in your area. The NEC Section 280 covers surge arrestors and provides general guidelines for their installation and protection. However, it's important to remember that the NEC is a minimum standard, and local codes may be more stringent. Therefore, it's always best to check with your local electrical inspector to ensure that your installation complies with all applicable codes and regulations. When selecting a surge arrestor, it's important to consider the voltage rating of the electrical system. The surge arrestor should have a voltage rating that is equal to or greater than the voltage of the system. This ensures that the surge arrestor can effectively protect the system from voltage surges. It's also important to consider the surge current rating of the surge arrestor. The surge current rating is the maximum amount of current that the surge arrestor can safely handle during a surge event. The surge current rating should be high enough to protect the system from the most severe surges that are likely to occur. When installing a surge arrestor, it's important to follow the manufacturer's instructions carefully. The instructions will provide detailed information on how to install the surge arrestor correctly and safely. It's also important to use the correct wiring and connectors. The wiring and connectors should be rated for the voltage and current of the system. Incorrect wiring or connectors can lead to electrical hazards. After installing a surge arrestor, it's important to test it to ensure that it is working properly. There are several ways to test a surge arrestor. One way is to use a surge tester. A surge tester is a device that generates a voltage surge and allows you to see if the surge arrestor is diverting the surge to ground. Another way to test a surge arrestor is to use a multimeter. A multimeter can be used to measure the voltage across the surge arrestor. If the voltage is close to zero, the surge arrestor is working properly. If the voltage is high, the surge arrestor is not working properly and needs to be replaced. Surge arrestors are an important part of any electrical system. They protect sensitive electronic equipment from voltage surges which can damage or destroy equipment. By following the guidelines in the National Electrical Code and the manufacturer's instructions, you can ensure that your surge arrestors are installed correctly and provide adequate protection. In addition to protecting equipment from voltage surges, surge arrestors can also help to improve the reliability of an electrical system. Voltage surges can cause equipment to malfunction or fail prematurely. By protecting equipment from voltage surges, surge arrestors can help to extend the lifespan of equipment and reduce the need for repairs. Surge arrestors are a cost-effective way to protect your electrical equipment and improve the reliability of your electrical system. There are many different types of surge arrestors available on the market. Some surge arrestors are designed for use in residential applications, while others are designed for use in commercial or industrial applications. It's important to select a surge arrestor that is appropriate for the application. When selecting a surge arrestor, it's important to consider the following factors. Firstly, the voltage rating. Secondly, the surge current rating. Thirdly, the type of equipment being protected. And fourthly, the environment in which the surge arrestor will be installed. Surge arrestors should be inspected regularly to ensure that they are working properly. The inspection should include a visual inspection of the surge arrestor for any signs of damage, such as cracks or corrosion. The inspection should also include a test of the surge arrestor to ensure that it is diverting voltage surges to ground. If a surge arrestor is found to be damaged or not working properly, it should be replaced immediately. Replacing a surge arrestor is a relatively simple task that can be performed by a qualified electrician. The cost of replacing a surge arrestor is typically much less than the cost of replacing the equipment that it is protecting. Surge arrestors are an essential part of any electrical system. They protect sensitive electronic equipment from voltage surges, improve the reliability of electrical systems, and are a cost-effective way to protect your investment. By understanding the guidelines in the National Electrical Code and the manufacturer's instructions, you can ensure that your surge arrestors are installed correctly and provide adequate protection. Remember to always prioritize safety when working with electrical equipment. If you are not comfortable working with electrical equipment, it's best to hire a qualified electrician to perform the work. Electricity can be dangerous, and it's important to take all necessary precautions to avoid injury. When working on electrical equipment, always turn off the power at the breaker box. This will help to prevent electric shock. Use insulated tools and wear rubber gloves to further protect yourself from electric shock. If you are unsure about how to perform a task, it's best to consult with a qualified electrician. It's better to be safe than sorry when it comes to electricity. By following these safety tips, you can help to prevent accidents and injuries. Now, let's further clarify the application of NEC Section 280, which specifically addresses surge arrestors. This section provides requirements for the installation, connection, and protection of surge arrestors. It's essential to consult this section of the NEC to ensure compliance with electrical codes. NEC 280.4 outlines the number of surge arrestors required at a service. Generally, a surge arrestor must be connected to each ungrounded conductor. This means that for a typical 120/240 volt single-phase service, 2 surge arrestors would be required, 1 for each hot leg. For a 3-phase system, 3 surge arrestors would be required, 1 for each phase. NEC 280.5 addresses the grounding of surge arrestors. Surge arrestors must be connected to ground using a grounding conductor that is sized according to NEC Table 250.122. The grounding conductor must be connected to a grounding electrode system that complies with NEC Article 250. Proper grounding is crucial for the effective operation of a surge arrestor. The grounding conductor provides a low impedance path for the surge current to flow to ground, preventing it from damaging equipment. NEC 280.6 specifies the wiring methods that are permitted for connecting surge arrestors. Surge arrestors can be connected using a variety of wiring methods, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and cable. The wiring method must be appropriate for the environment in which the surge arrestor is installed. NEC 280.7 covers the location of surge arrestors. Surge arrestors must be located as close as practicable to the equipment that they are protecting. This minimizes the length of the wiring between the surge arrestor and the equipment, which reduces the impedance of the wiring and improves the effectiveness of the surge arrestor. NEC 280.8 addresses the connection of surge arrestors to the electrical system. Surge arrestors can be connected to the electrical system in a variety of ways, including directly to the service conductors, to a branch circuit, or to a separately derived system. The connection method must be appropriate for the application. When connecting a surge arrestor to a branch circuit, it's important to ensure that the branch circuit is adequately rated to handle the surge current. The branch circuit breaker should be sized appropriately to protect the wiring and equipment on the branch circuit. As previously mentioned, squared D surge arrestors often come with internal overcurrent protection. However, it's still important to verify the specific requirements for the particular model of surge arrestor that you are using. The manufacturer's instructions will provide detailed information on the installation, connection, and protection of the surge arrestor. In addition to internal overcurrent protection, some surge arrestors also include other features such as status indicators and remote monitoring capabilities. Status indicators provide a visual indication of the surge arrestor's operating status. Remote monitoring capabilities allow you to monitor the surge arrestor's performance remotely, using a computer or other device. These features can be helpful for troubleshooting and maintenance. When selecting a surge arrestor, it's important to consider the specific needs of your application. If you are protecting sensitive electronic equipment, you may want to choose a surge arrestor with a high surge current rating and advanced features. If you are protecting a less critical load, a simpler surge arrestor may be sufficient. Remember to always consult with a qualified electrician to ensure that your surge arrestor is installed correctly and provides adequate protection. A qualified electrician can assess your electrical system and recommend the appropriate surge arrestor for your needs. They can also ensure that the surge arrestor is properly grounded and connected to the electrical system. In conclusion, understanding the NEC requirements for surge arrestors and following the manufacturer's instructions are crucial for ensuring the safety and reliability of your electrical system. Surge arrestors provide valuable protection against voltage surges, which can damage or destroy sensitive electronic equipment. By properly installing and maintaining surge arrestors, you can protect your investment and improve the performance of your electrical system.